So this question comes from 8.5, and it asks us to use the to expand the logarithm. And so we're going to be using some of the properties of logarithms that we've talked about in this chapter, and we want to expand this fully. So in order to expand it fully, the first thing I see is that I have this division sign. And so because I have this division sign, I can take and rewrite this. This is the log base 10 is the common logarithm. And I can say that the log base 10, or just the log of a times the sixth root of b, minus the log of c times d to the ninth. So I can rewrite it in this form. And that is because of the quotient property. The quotient property says I can rewrite this single logarithm if there's a quotient here with a subtraction sign here. Now I'm going to expand this further. And I'm going to say, all right, I'm going to focus on this logarithm first. And I'm going to say, well, these two things, a and the sixth root of b, are multiplied together. So, and because they are multiplied together, I can expand them using the product property. And I can say the log of a plus the log of the sixth root of b. Then I have minus the log of c d to the ninth. So this is c times d to the ninth. And now I'm going to focus on rewriting this part. And actually, I guess before I do that, let's finish expanding this fully. I guess I should try that first. So this one is expanded fully. It's just the log of a. But this one I can rewrite as the log, instead of the sixth root of b, I can rewrite this as b to the 1/6. Because radical, this is a radical, the sixth root of b. Radicals can be written as a fractional exponent. So whatever the root is, this is the root or the index, you can say it's 1 over the index number. So this means the same as that. And so now once I do that, then I can take this exponent, the 1/6, and I can move it down in front. And so this right here, and that was called the power property, can be moved down in front and multiplied. So now I have fully expanded this first part. So now I'm good to go here. This is fully expanded. I can't simplify any further. And so now I'm going to move my focus to this log of c times d to the ninth. And so I'm looking to expand now this portion. So what I do is I'm going to rewrite this front part. And then I'm going to work over here with this log of c d to the ninth. And so because this is multiplication, just like the first part here, a times the sixth root of b was multiplication, I can expand that into the log of c plus the log of d to the ninth. Now you'll notice that I put this in parentheses. And the reason why I put this in parentheses is because it's subtracting this whole thing. It's not just subtracting the first part, but it's subtracting this whole thing. So I have to kind of remember that I'm subtracting both this and this. So I'm distributing that minus to both of these. And so I would get the log base 10 of a plus 1/6, the log base 10 of b. And you don't have to say base 10, it's just the common logarithm. So you can just say log and then it would be minus the log of c, and then that minus, and I'll pull this exponent down using that product or the power property. It'd be minus 9 log of d. And so now this would be fully expanded, and this would be my answer here. So we have to remember that that minus sign is going to distribute out to both of these.